Welcome to another video. In this problem of algebra equations of x raised to the power 2 plus 2x all raised to the power of 2 equals to 9. And can we solve for the value of x? And it's very simple to solve. And if I just come into our channel, please remember to subscribe and turn on the notification bell. So we know from this, if I take out x squared plus 2x, so the condition is this value is always greater than 0. And if it is greater than 0, then by taking out x, then we have this as bracket x plus 2, and we agree that this is always greater than 0. But we have some conditions attached to the value of x. So if this is truly will be valid, the first one is the value of x itself is greater than 0. So and if it is greater than 0, then and we are going to have the x again, which is also greater than minus 2. So according to these values. And this is now implies that the x itself is greater than 0. All right. So if this first condition is odd, and we can now verify for the second one. And suppose we say have x less than 0, so based on the negative side. So we know that the x again will be less than minus 2. And if it is less than minus 2, it implies that the value of x here is less than minus 1. So if all these conditions satisfy for the value of x, then we can now solve the given problem, which is x squared plus 2x all raised to the power 2 equals to 9. But the way I'm going to solve this is I'm not going to expand the bracket, and we know from here, if you have the absolute of x, it has two possible values. So the first one is it can be in form of plus x, and it can also be in form of negative x or 0 otherwise. So given this, we're now going to recall from the problem, as if you now introduce the absolute to it, like x squared plus 2x with its raised to the power 2 equals to 9. Then by taking the absolute of this, so we are going to reduce 9 to 3, and we have this as absolute of x squared plus 2x. This equals to 3. So we have applied the rules of complex number here and the rules of absolute. Okay, and we know since this is working with positive and negative, so the first case is bracket x squared plus 2x equals to 3, and the second case is going to be minus bracket x raised to the power 2 plus 2x equals to 3. And then we can now solve these two problems separately. So for the first one, if you have x raised to the power of 2 plus 2x, if we transfer negative 3 here, we have equals to 0. And by looking at this, by comparing it with these standard quadratic equations, we have ax squared plus bx plus c equals to 0. And we know the value of a is coefficient of x squared, which is 1, and b is 2, and c is minus 3. Following this quadratic formula, which is minus b plus or minus b squared minus 4ac divided by 2a. And then we know from here we have d equals to b squared minus 4ac, which is the one in the root, and d is known as discriminant. So let's plug in the value of b, a, and c. As b is 2, which is 2 squared is 4, minus 4, and a is 1, then c is minus 3. And the entire of this one becomes 16, and we know 16 is greater than 0. So anytime the discriminant is greater than 0, we know the value here is going to be real, as we have x is minus 2 plus or minus the square root of 16 all divided by 2. So which this is equivalent to minus 2 plus or minus 4 divided by 2. So for this, if we work with both positive and negative separately, we are going to have the end result of this to be the first one is going to be 1 and minus 3, or minus 3 and 1. Okay, so we can now conclude that we have minus 3, 1, which is a member of real number as discriminant greater than 0. And both of these are highly acceptable according to the given conditions above. Then we can now deal with the second one, which is the negative part of this. And you know, if you are given this the second problem like that, so I can just say this is x squared plus 2x. You know, this one is going to be plus 3 when we transfer it, or let's say I transfer negative to that 3, so it becomes minus 3. So why this is x squared plus 2x plus 3 equals to 0. And at first, looking at this problem, you know, discriminant will always less than 0 here, because by trying to plug all this value in the b squared minus 4ac, we have 4 minus, you know, we have 4 times 1 times 3, and that is 12. You know, this is going to be minus 8 and less than 0. So when discriminant less than 0, it means that the roots are imaginary, that is, the roots are complex. So we have this as minus 2 plus or minus 8 divided by 2. And again, so we have minus 2 plus or minus. You know, this can also be written as the square root of 8 multiplied by minus 1. And we divide everything by 2. So we should also know that this minus 1 is just like I squared according to the complex. So we are going to replace this minus 1 with I squared. Then we have x equals to minus 2 plus or minus. So we have the root of 8 multiplying I squared divided by 2. So which is equals to minus 2 plus or minus, you know, when we separate this with individual roots, so I squared reduced to I, and this root 8 reduced to 2 root 2, and all divided by 2. So by factorizing out 2 in this problem, we are going to have x equals to, you know, we have minus 1 plus or minus I root 2. So and here is a complex root, that is the value of this x1 comma x2, so is a member of a complex number. And this is how this problem is done. Thanks for watching, and again, don't forget to subscribe to this channel, and in case you have another way of doing this, you can drop it in the comment box. I will dearly appreciate it. Thanks for following, and don't forget to like and share this video. Never stop learning. Bye bye.